Mexico's Smoking Mountains by Nancy Finton. Page 3. El Popo. Imagine that you live in the city of Puebla in central Mexico. At 7,000 feet above sea level, the city is high and dry. Your view of the surrounding mountains is crystal clear. As you shop at the open-air market, you glance toward El Popo, the beautiful snow-capped volcano about 30 miles to the west. It is so familiar, it is almost like an old friend. Suddenly, you see a shocking sight. Smoke and ashes are pouring out of the volcano. Red-hot rocks are shooting 2 miles up into the air. You cut short your shopping trip and race back home. Page 4. At home, you find your family gathered around the radio. The volcano is about to erupt. Now the government is telling people to leave the area. Your father is not eager to go. He doesn't want to leave the animals behind on your farm. And he's afraid the crops will be destroyed. The volcano has been restless all week, but now it's letting off more smoke than before. Your father knows that a major eruption could come at any moment, so you and your family pack up a few belongings and head for a shelter. On the road, you follow a long line of cars and trucks filled with families looking for a safe haven. Everyone plans to keep a safe distance away until the volcano settles down. That night, your family settles down to spend the night at an outdoor campground. Despite the undercurrent of fear caused by the government's warnings, the campground is quiet as day changes to night. You wonder if all the effort of packing and leaving was really necessary. Then, as you watch, from the distance, El Popo blows its top. It throws hundreds of fiery rocks into the dark sky. At times, it looks like the grandest fireworks display you have ever seen, but the scene is horrifying as well as beautiful. You know that eruptions like this can cause terrible damage, and you worry about your home. Will the house and the farm animals be all right? Page 5. Mexico's volcanoes. El Popo's full name is Popocatépetl. Popocatépetl means smoking mountain. The Aztecs living in Mexico a long time ago named the volcano. At 17,887 feet, El Popo is one of Mexico's highest mountains. El Popo is also one of Mexico's most dangerous volcanoes. Its violent eruptions date back to the year 1347, and perhaps even earlier. Today, about 300,000 Mexicans live near El Popo. In a serious eruption, many of these people could be at risk. Page 6. El Popo had a major eruption in 1927. After that, the volcano was dormant for nearly 70 years. Then, in 1994, El Popo came back to life. It sent up small plumes of smoke, gases, and ash. Since 1994, scientists have watched nervously, wondering what El Popo would do next. El Popo is only one of many volcanoes in Mexico, one of the world's volcanic hotspots. One Mexican state, Michoacán, has more than 80. Several of Mexico's highest peaks are either active or dormant volcanoes. In addition to El Popo, these include Citlapetl, Mexico's highest peak at 18,700 feet, and Iztaccíhuatl, which reaches a close 17,342 feet. In addition to the volcanoes, the region's countryside has hot springs, dried lava flows, and ash deposits on the land. Each of these features is a sign of volcanic activity. Mexico even has one of the world's youngest volcanoes, Paricutin. The sudden appearance of this volcano in a farmer's cornfield in 1943 is a dramatic and unusual story. On the morning of February 20th, 1943, a farmer checking on his corn found an 80-foot-long crack in the middle of the field. The crack had simply opened up during the previous night. As the farmer and his family looked on, smoke, ash, and red-hot rocks began to pour out of the crack. Page 7. Amazingly, they were watching a volcano being born before their eyes. The rock, ash, and lava that came from the gap began to accumulate. By the next morning, the new volcano had grown to a height of 33 feet. After a week, it was 550 feet high. Eventually, the people called the volcano Paricutin, named after a nearby village. The volcano continued to grow with remarkable speed. Over the next 9 years, it grew and grew. By 1952, when it stopped growing, it was over 1,300 feet high. During those 9 years, it spewed more and more rock, ash, and lava over the countryside, causing 4,500 people to lose their homes. Page 8. Mexico and the Ring of Fire. If you look at a map of the world with all the known volcanoes highlighted, you will notice that almost all of the world's volcanoes are found in narrow lines or belts of volcanoes. In between volcanic belts, there are few volcanoes. For example, the coastal range across the North American continent and the Pacific Plate is one of the most active volcanic areas in the world. Another series of volcanoes form the Hawaiian Islands. Like most volcanoes, the ones found in Mexico are part of a larger pattern. They are part of a remarkable chain that stretches along much of the coast of South America. You can find volcanoes all through the Andes, the high mountains that loom over South America's western coast. This line of volcanoes is also part of an even bigger pattern, the greatest volcanic belt in the world. It is a huge circle of volcanoes that surrounds most of the Pacific Ocean. This circle is called the Ring of Fire. Overall, there are more volcanoes in the Ring of Fire than in the rest of the world combined. Some of the most famous volcanoes in the United States are part of the Ring of Fire, including Mount St. Helens in Washington State and Lassen Peak in California. There are also many volcanoes and volcanic sites along the coastline of Alaska, and especially in the Aleutian Islands. Page 9. The Ring of Fire includes Japan, with more than 70 active volcanoes, and Indonesia, with over 125. Some of the world's most powerful volcanoes are in this ring too. They include Mount St. Helens, Mount Pinatubo in the Philippines, and mighty Krakatoa in Indonesia. When Krakatoa erupted in 1883, the blast was heard 3,000 miles away. Page 10. Explaining volcanoes. Because volcanoes are so powerful and unpredictable, people have always needed to explain them. Lacking scientific explanations, early cultures used myths to explain these frightening exploding mountains. Ancient Romans, for instance, thought volcanoes were the chimneys of Vulcan, the fire god. The word volcano comes from the name Vulcan. Vulcan worked as a blacksmith at the heart of volcanoes like Mount Etna. The fiery eruption of a volcano was just the sparks and flames of this forge flying upwards. Vulcan crafted many things while working at his forge, including the thunderbolts that the god Jupiter hurled at his enemies. Popocatépetl has its own legend. Itza and Popo were gods who loved one another. Before they could marry, Popo's enemies informed Itza that Popo had been killed. Itza promptly died of a broken heart, and when Popo heard of her death, he in turn died of a broken heart. The gods mourned for the dead lovers, and turned their bodies into volcanoes so that they could stand side by side forever. Today, people demand more than myths to understand volcanoes. They look to science to explain volcanic activity. The scientists who study volcanoes are called Volcanologists. They spend years closely following the behavior of volcanoes like El Popo. Page 11. Volcanology, the study of volcanoes, is still a young science. Scientists began to observe and record volcanic activity systematically in the 19th century. But this young science has developed quickly, perhaps because so many lives have depended on its rapid development. Since 1900, volcanologists have gathered huge amounts of information about the history of volcanoes and how and why they erupt. Volcanologists have also come up with some amazing theories about the importance of volcanoes in shaping our environment. For instance, some think that the Earth's atmosphere is made up of gases released by volcanoes. Other scientists even think that all the water on Earth may have come from volcanoes, including the water in the oceans. The most important thing scientists have learned, though, is how to predict eruptions. By predicting eruptions, they can save lives, just as they did at Puebla, Mexico, when Popocatépetl erupted in the year 2000. Page 12. Volcano Basics. Before scientists could start predicting eruptions, they had to learn how volcanoes work. That understanding begins deep underground. Like mighty Vulcan hammering away at his forge, terrific forces are at work inside the Earth. The Earth is covered with a layer of rock called the crust. Beneath the crust, soft, hot rock forms the Earth's mantle. The crust is broken up into pieces that fit together like a jigsaw puzzle. Where these giant puzzle pieces meet, they grind and bump against each other. This grinding can generate huge amounts of heat from the friction. Along those gaps, surrounding rock is sometimes melted by all that heat. The molten rock, called magma, sometimes escapes through the crust. As it pushes through the surface and cools, it forms volcanoes. When magma seeps through the crust, it flows out as thick, burning hot lava. Magma can also surface in a more harmful way. It can burst out in clouds of intensely hot smoke, ash, and rocks, reaching well over 2,000 degrees Fahrenheit. Page 13. Volcanic destruction. In some ways, volcanoes are more dangerous today than ever before, because now more people live near them. That means more people could be at risk in a serious eruption. Lava from volcanoes can bury whole cities. Violent eruptions can also set off dangerous landslides. And in the ocean, volcanic eruptions can create deadly waves called tsunami waves, which may grow tall and slam into shorelines. Volcanic eruptions are especially dangerous when the volcano is covered with ice and snow like El Popo. On mountains like these, eruptions can melt the snow. All that water and the vibration of the earth can cause the mountainside to give way and dissolve into a huge mudslide. Page 14. Since volcanoes are so dangerous, it's no wonder scientists pay close attention to them. El Popo, for example, has an army of scientists watching its every move. To predict an eruption, scientists fly over a volcano in a helicopter and measure levels of gases in the air. They also put instruments underground to check for tremors in the ground, and they have special equipment that measures any bulges in the volcano's surface. When scientists find trouble signs, they swing into action to alert the government about the danger that might be brewing. Page 15. At some volcanoes, scientists even climb down into the craters to carry out tests and measurements. Wearing special protective suits and carrying special tools, they collect blobs of hot lava to study in their laboratories. Needless to say, exploring a volcano crater is dangerous work. Though the suits protect against heat, they can also make it hard to see and wear and hear what is going on nearby. The suits are also heavy and clumsy to move around in. Some volcanologists have lost their lives collecting data from active volcanoes. Page 16. The risk of studying volcanoes is great, but the rewards are even greater. When El Popo erupted in 2000, early warnings from the government saved thousands of lives. Many more lives will be saved in the future from similar warnings. Tomorrow's safety starts with today's science. Nobody knows if El Popo is going back to sleep or getting ready for an even bigger eruption. One thing is certain, though. If you lived in El Popo's shadow, you would do well to keep your eyes on the volcano and your ears tuned to the radio for the latest scientific report. The end.